Welcome back to Black Robot. Today's topic in number systems, binary, hexadecimal, and Endianness basics. Why this matter? Because in embedded systems, everything registers, GPIO, memory addresses, communication packets is expressed in binary or hex, and Endianness decides how those numbers are stored and understood. By the end of this session, you will clearly understand how computers represent numbers, why engineers prefer hex, and how byte ordering affects embedded and IoT communications. Why number systems? Humans use decimal base 10, but microcontrollers only understand binary base 2. In embedded systems, registers are set using binary or hex. GPIO pins are toggled using bit mask. Protocols define data order and DNS. So it is essential for embedded and IoT engineers. So basically, you can say here, DNS defines how data is stored into the memory, and register memory protocols all rely on to the binary or hex format of the data. So if you are seeing computers, okay, so computers and microcontroller, because inside these computers, chips are there. In that chips, a microcontroller or microprocessor is given there, which only understands 0 or 1. That's it. So what is decimal value here? So those values, placed from 0 to 9. So decimal is basically having base 0. We can say that base is not 0, my bad, base 10. Okay. So when you will start counting from 0 to 9, it is having 10 numbers. It means it is having 10. Okay. So if you are seeing here 357, so 3 into 10 to the power 2 is defined here. So it means it has become 300 plus 5 into 10 to the power 1. This is power 1. So it has become 50 plus 10 to the power 0 into 7. So it's 1 into 7. So totally it has become 357. So this system is natural for humans because we count with 10 fingers. But for machines, decimal is insufficient. Binary. So binary always have a base 2. Only 0 and 1. Only two digit is there. 8 digit is having 8 bit. So 8 bits is equal to 1 byte. In hardware, 0 means 0 volt, 1 means 5 volt. So you can say it is a low and it is high. So if you are going for, you know, these numbers, okay, for the suppose into the embedded systems you have defined as a port because into the controllers, suppose you are having controller, later we will, learn more about that, how you are going to define having A, B, C, D like that. If you want to just make it high as a 1, means given as a, uh, you know, you want to add the LED as on because if you will make it on, it means you are giving a 5 volt, it means it is a 1. If you are making as a off, it would be 0 volt and it would be 0. Okay. So in that case, how you will define that? Okay. So in that case, you will define port A is equal to 0 V 0 0 0 0 0 1. Okay. So LED of pin 1 is high. Apart from that, others are in low. So if you want to make two pins high, you can make it this place like that. Okay. So this is how define it. So high signal on you are making is a high signal onto the pins here and 0 for a low. So if you are defining decimal to binary conversion, what is decimal to binary conversion? To convert decimal to binary conversion, binary divide repeatedly by 2. Okay. So if you are having this number 13, how you have got 13 here? So 13 divided by 2. Okay. So you will get it 2 6 the 12. It means remainder is 1. Okay. 6 divided by 2, it would become 0. 3 divided by 2, it would become 1. 1 divided by 2, it has become 1 remainder. So this is remainder what you are seeing. So the binary value would be 1, 1, 0, 1. Got it? So you can practice from yourself these, seeing the binary, how you are defining it for 13 divided by 2, and also for 252, you can define this one. So registers in microcontrollers are controlled in binary. So for port 1, just now we have talked about it, how you are enabling the pins of controllers. So 0 here, so it has become 0, B, 0, 0, 0, 0, 0, 0, 0. So it means all LED is off. Okay. So each bit sets a one pin state if one is there. So this is how you define it. This is how we control hardware directly with binary. So here B means binary. So in binary numbers, LSB and MSB is there. LSB means least significant bit. It means right most bit. So right most bit, it is the smallest value. MSB is most significant bit is there. It is the leftmost bit, which is the largest value, and this is the smallest one. Okay. So for example, if you're seeing in 1011, MSB is 1, got it, and LSB is also 1. Okay. This is the least significant bit. This is the most significant bit, MSB, LSB. So LSB, this value, LSB often represents simple on-off flag. So LSB represents on off into the embedded system. It's on off flag usually. And MSB sometimes used as a sign bit or error indicator. Okay. So if you're seeing here how you can get it, uh, device is ready. So in that case, check here, if you are writing here if status and you are giving the operators and operator. Okay, 0B, 0, 0, 0, 0, 0, 0, 0, 0, 1. Okay, so it will show the device ready if it is the true condition. Device ready. Why? Because you are comparing with this least significant bit, which is the on-off flag. So this is how it will picking the LSB of a status register. Why hexadecimal? Any thoughts? Because earlier start of this lecture, as I told, computers and microcontroller processors usually, yeah, we usually look for the hexadecimal values. So binary is powerful, but too long for the humans. Okay. So hex is compact. It means 4 bits is equal to 1 hex digit. 4 bit is equal to 1 hex digit. Data sheets, registers, and memory addresses are almost always written in hex only. Okay, it is used for the register memory address and protocols, all the things. So for GPU, GPIO register bit address, if you're seeing any GPIO register into the controller, you will be seeing you will be seeing into this hex format 0x 4002 like that, right? So this is the base address, you say, base address of the GPIO pin. So in that case, if you're seeing here decimal to hex to binary, so 0 to 0 converted 001 and 9 to 9, it's binary. If you're seeing 1001, then addition A as a hex and 101 as a A only. So it's in binary format. 15F111. So binary easy mapping between binary and hex is given there. Only you need to see how it is mapping. So you can practice from yourself using different numbers there. So it would help you how it is converting. And also there decimal to hex example, if you're seeing here. So in that example, decimal 255, it is defined as 0xFF. For 16, it is given at 0x10. For 4095, it is 0xFF. Okay, so this is what you will get the output for these values. So for decimal to hex, if you are converting there, so this is the numbers convert into this format. So hex into the C usually defined with the prefix 0x. If int x is given there and it is assigned 0x1 with, so in decimal it would be 26. So it will print the 26 because 0% D you are adding here, so it's a decimal value we'll be getting. So what if int y is equal to 255 and you are printing here? Okay, what would be the value? My bad. If you are getting 0x FF, what would be the value? So forget about 255, my bad, it's a int value, decimal value, it's 0xFF should be there as a hex format. So when you are printing as a decimal, again, any thought there because I will tell you, so you will get it 255, okay, into the decimal. So hex values are natural in embedded because memory mapped registers are written in hex. Okay, so that's why these registers are written in hex. Binary to hex mapping. Hex digit are 4 bits. Okay, if you are converting this to this one, so you will get a 0xf. So always you are seeing first four. So 1010 is basically A. Okay, and 111 is basically F. So this is how you define it 0xf. So hex is the bridge between two binary numbers. So you can say it's a bridge between binary hardware and human readability, basically. So also the further, so into the example, if you're seeing again 0x, how you have got it, right? So in that case, these four numbers and these four numbers, this has become D and this has become A. Okay. And in that, and also further, if you're seeing 7B, So what binary you have got? You have got this binary. Okay, so you can see 7 this would become, and B this would become. Okay. In octal systems, how does this perform? It goes from 0 to 7 here. So not being used in embedded nowadays, but in Linux Unix is used for file permissions like chmod 755. Okay, so we use for the Linux file permissions usually nowadays. Octals, it prefix is 0. Okay, so when int is x is equal to 0, 755, so it's octal literal. So this represents file Linux file permissions. Okay, so Linux file permissions basically in format of R, W, R, X, XR. If you are working on Ubuntu, okay, unless you have given this all of the files you will get it, and in that case you will be seeing somewhere file permissions as well. So what is Endianness? So this is the main thing you need to know about here. Endianness is basically byte ordering in memory. So it also, defines how multi-byte data is stored. Okay. So if you are seeing here the example in M is equal to 0x1, 2, 3, 4, 5, 6, 7, 8. So 12 would be the MSB and 78 would be the LSB. So So this is the two storage possibilities. So in that case, the MSB stored first, okay, and LSB stored lowest into the last there. So think about that. Writing a phone number left to right versus right to left, both represents the same number, but the layout differs in memory. Okay. So what is big versus little Indian here? So if you're seeing the same thing, how it is stored 1, 2, 3, 4, 5, 6, 7, 8. So MSB stored first and LSB stored first into the little Indian format for okay. So into the big Indian. So it's 12, 34, 56, and 78 has become. So this is the big Indian. So if it is a little Indian, so LSB stored first. So this is the LSB 78, right? So it will store first into the little Indian format. Then 56 has come up, then 34, then 12 has come up. So this is what little Indian format is there. So in that case, it's the same value but stored differently in both cases. What is memory layout there? So if you are seeing memory layout example there, so not so memory can be, what is memory layout into the controller. If you're seeing here this memory, so it is started with 0x 1000 there, 0x 1004, some integer is stored again, 0x 1000 at it has stored. So this is a memory layout. Okay, so we will discuss more about memory layout later, how it is given into the controller. So suppose variable starts as address 1000. For a big Indian, at the address, it is stored 0x1b. At address 1000, it is 0x34. In next address, it is stored 0x56, and in next address, it is stored onto the 1003. For a little Indian, 0x78, it is stored 1000. So 0x56 is stored 1001, and 0x34 is 1002, and 0x12 is stored at 1003. So in that case, big Indian is equal to, write book pages in normal order. So little Indian is what is basically it is stack pages in reverse. So debugging raw memory dumps requires knowing system Endianness. So when you are debugging the memory into the embedded systems, you will have to have this knowledge about the Endianness, how Endianness, that how data stores into the Endianness. So why Endianness matters? So if you are seeing the sensor sets by 0x12 and 0x34, So in that case, big Indianness interprets as a 0, 1, 2, 3, 4. If little Indian system is there, so it would print as a 0x3412. So it's a complete different values. So that's why TCP IP protocols always define network byte order. Network byte order. Okay. Network byte order. And it is a big Indian. Okay. So how do you detect Indianness into the C if you're seeing this code, right? Then this code, in that case, store integer one at to the memory location 0x 000000001. So this one has stored into onto the this memory address and take pointer to first byte. Okay, so you will have to take to pointer to first byte here. So if byte first, this pointer, you will have to take pointer to first byte. Okay. So if first byte is one, so it's a little Indian. Okay. If one, it's a little Indian. So address, if you're saying you have defined. Okay. If pointer C. So if it is pointing to the first byte. So it is pointing to the first because address you are mapping here and of X, right? So character pointer X because the value which you are storing address here, it will store into pointer C. If first byte, the it is taken to the first byte, then little Indian. If first byte is zero, okay. If first byte is zero, then big Indian. Zero means big Indian, one means little Indian. So mm, there is a trick into the bootloaders and embedded system forwards. We will learn more about these things later. So Indian is in embedded systems, how it basically works. So when you are working onto the ARM Cortex and similar kind of controllers, so that's a little Indian. Okay, when it is networking, it's a big Indian. Okay, and so it works onto the different platforms. Different Indianness can be there, and also uh, Intel 0x86 is also the little Indian there. Okay, and so TCP/IP, CAN protocol, Ethernet, all is uh, big Indian. TCP/IP, CAN is there, and Ethernet cable is there. So, for example, okay, for example, sensor sends okay 0x12 and 0x34. So we have discussed about how we'll store, right? If little Indian is there, so in little Indian it will store as a 0x3412. And if it is big Indian there, 0x1234. So wrong, you will get if there is a wrong value. So if you are not, unless it is converting. So that's why functions like htowns and htwnl exist. Host to network conversion is there. So in IoT, ignoring Indianness means corrupted sensor data you will be getting. So you should not ignore the Indianness of the sensor data there. You will always have to check the protocol. So what is the best practices you need to perform? Always know systems Indianness. Use hex for registers, not decimals. Comment binary mask. Convert data before transmission. Okay. So, for summary, what we have discussed till now, decimal is human system, binary machine system, machine numbers is there, hex is compact, binary Indianness is byte order in memory. Together, these form the language of hardware. So basically, number systems are the foundation of embedded programming. If you master binary, hex, and Endianness, registers and communication protocols will never confuse you again. So next up, we will move into the electronics and logic basics, where these number system control real circuits. So if you have any questions, you can comment into the comment box. I will try to answer there, and we will be exploring more after this lecture. Thanks everyone.